Okay, let's get this party started. Hey everyone, welcome to Soroban Design Discussions. Today, we're going to talk about two topics, transient storage and upgradable contracts. I'm going to take over Justin, and I apologize in advance for my nasal sound. I'm a bit congested. Is Dima here? Yes. Dima, do you want to take us through transient storage?
Yeah, sure. So this is really a pretty small feature, and I don't really want to spend too much time on it. Like, if you think we don't need it, let's just drop it. But basically, the idea is that with OS Next, the cross-contract interactions are much more capable than without it. For example, um, if a contract wants to do some temporary allowance to distribute funds between multiple receivers or something like that, it could call the increase allowance function and then do the corresponding transfer form call, right? And the thing is that allowance in this case is not needed to be persisted. And my initial intention here, why I came up with this idea in the first place, is that I didn't want the token to have any persisted allowances, but yeah, this was a topic we have discussed last week, and it doesn't seem like the general consensus is that for the time being, we want the persistent allowances to still remain in the token. Yeah, but originally the idea was if you want to create something that is needed only for the duration of the top-level contract execution time, you could use this ephemeral storage or whatever the name is, and basically the benefits were that it doesn't need to be included in the footprint, and it doesn't need to be written to the ledger, which is beneficial both from the transaction size standpoint, the transaction cost standpoint, and it's beneficial for the ledger as well. And the last thing is that from the interface standpoint, it probably will be pretty simply to use from the SDK perspective because we can abstract it away if needed and make some generic interface where maybe you can switch a flag or something. So I wouldn't be too concerned about the SDK side, but I guess the main concern is that well, there aren't too many use cases for that, at least yet. And I kind of agree, especially if we just don't want to go with temporary allowances and we go with persistent allowances. Yeah, I think I don't really want to blow the token interface with like multiple allowance types or something like that. So, we can drop it or we can leave it, but not use it in token. I don't have a really strong opinion. Like, there are definitely some interesting cases one can come up with where, one contract calls another contract multiple times and another contract may want to maintain some state, but yeah, maybe these cases are too narrow to worry about them now. So I guess that's all I have to say for now.
Got it. So it is worth mentioning that this thing has been discussed a lot in the Ethereum ecosystem, and I think they're getting pretty close to actually putting something like this. That's the IP 1153 transient storage opcodes. And in the Ethereum ecosystem, it's also something that's been considered in the context of reentrancy attacks because it allows you to basically kind of like a contract can set a flag that it's like being processed right now, and then if there's like a reentrance, then the contract can check that flag. I think for us, it's less relevant right now because there's no reentrancy possibility at all. And I think that if we're gonna add reentrancy possibility, there's probably gonna be a flag in the call function that allows you to set like whether or not you accept that. So I think that's less of a motivation for Soroban. Um, uh, my question to you, Dima, and I think I asked this in the past. Aside from the allowances use case, are there any other examples that you can point out to?
So, actually, speaking of reinsurance, I think if we do it in whatever ways, this might be actually useful. I just forgot to talk about this. I don't know if I don't think there are plenty reinsurance for V1. Maybe eventually. I feel like it will be beneficial to be able to write some protection bits, even if it is controllable on the individual contract call level. But otherwise, I don't think I have a super good concrete example. I've been thinking generally about OS tickets for approvals. It's just a case of that, but in general, you can imagine something like a custom account, a smart wallet creating some authorization tickets that might be used during the contract execution time for multiple calls. But I guess the main issue here is that since this thing like this does not exist, for example, in EKH yet, right? I guess there aren't many users of that because, well, there's no such feature. So yeah, but I cannot come up with like a very convincing case right now. Like I have just some vague ideas. I don't know if they can be implemented efficiently in other fashion. Maybe they can. Yeah, but the important part is that, well, yeah, like I understand that use cases are probably not that obvious, but also the maintenance cost is pretty low as well. So it's not like a huge trade-off. It's not like a complicated subsystem we need to maintain as well. So yeah, that's something to take into account.
Got it. So I think that given that last week we decided to keep long-lasting approval or persistent approvals, and given that simple authorizations are handled by Authnex without actually requiring allowances at all, I would say that this is a pretty narrow use case um, and will clutter the asset interface. So I definitely agree with the sentiment that we shouldn't include it. And I wonder if anyone else on this call has a different thinking about that.
So you're saying not only remove it or like don't make any changes to the token contract, but also remove it from end in SDK, right? Because it's been that like the tooling for this has already been implemented, right?
Yeah, my vote would be to remove it,
Okay.
especially given that it's such a narrow use case, and also, with state expiration, we have a lot of different storage mechanics in the env, and I think that adding another storage mechanic can just add to the product confusion for developers.
Yeah, I agree. If we're not going to use it, then and we don't have any other good use cases, I'm fine with removing it.
Yeah, I tend to agree as well. It does sound like a very cool feature, but it also, to a large degree, it's an optimization, and yeah, there definitely is like a complexity cost to developers needing to be aware of this thing. So knowing that it should or shouldn't be in a footprint, which I guess is largely taken to care of by the fact that we generate the footprints for people, but developers needing to make a choice about what they use. It just seems like one more thing that people need to know or learn about or make a decision about. That for the most part, it sounds like we would be telling people, don't use this. This isn't something that you would use, except for these edge cases.
I don't have a very strong opinion. I can imagine finding use cases for it, but if we're aiming for minimalism, then I guess we remove it. I don't really care.
Is it in the current release? The release that's just gone out now?
No.
Okay, it sounds like we're pretty in agreement right now on removing this. So I will we'll go to the next topic, which is upgradable contract.
Yeah. One small thing on this, like since it is in the current release, someone comes up with a good idea of a use case, please let me know. Because if there is something legitimate that people can use right now and they can play with it, so if it seems useful, like we can reconsider this, right? Because
It's not in the current
there will
release.
be. Oh, it is not.
No, right.
Oh, okay. That's a bit unfortunate. Well, okay. I guess you still can write if you have some ideas.
Yeah.
Yeah, Mutz is asking if it wouldn't be complicated to include post mainnet. It will be somewhat complicated in a sense that it will require a protocol release, but yeah, it just will be long, not complicated.
Okay. Next topic is upgradable contract. So Dima, you distributed a doc a couple weeks ago that outlines 3 different proposals, and you've implemented one of them. Can you give us a brief overview on the problem and the different solutions, and focus on the one that you're proposing?
Yeah, sure. Basically, I think we want some contract upgrade mechanism to be shipped in V1, just because if there is no such mechanism, then contracts written in V1 will stay unupgradable forever, because no matter what mechanic we come up with, it will need to be controlled by the contract itself. And if contract doesn't have an upgrade mechanic, there is no way it can upgrade itself. So it is, of course, possible with the current tool set to build something like a proxy, but the issue is that the state will need to, like the state of the proxy contract has to belong to the top level contract ID, and currently it's not possible to achieve that. So we need something to address this issue. Which is why I had in the proposal this option 1 where I said, okay, we could add some sort of storage delegation mechanism, which I think someone put it existed in Solana, or maybe some other chain. I believe it was Solana, but I could be wrong here. But basically, it's just one of the approaches that is possible, where you say, hey, I allow not I, yeah, I allow that contract I'm calling to actually be using my storage. It's not super straightforward to implement, I guess. And also it is going to be relatively manual in terms of like, besides the storage delegation mechanism, you still need to write all the proxy machinery, which might be an overkill for some cases. So second option and third option, but basically 3 depends. Option 3 develops on the option 2, and yeah, for the option 2, what we do is we just allow the contracts to update their contract executable entry, as we call it now, where basically contract says this is a reference to my implementation, where the reference is hash of the WASM blob installed in chain. So with this proposal, like the PR is already there, we just allow contracts to call a host function and update the hash of this WASM blob to be some other value, which performs an update. So basically, the update logic and authorization logic is on the contract developer, which makes sense. I want to have different authorization approaches to this. But the main point is that it is now possible to just upgrade the WASM that is being used. As an addendum to that, as a few folks suggested, and I have this implemented as well, we'll add WASM hash to the standardized signature payload for the auth. just so that we'll basically get some feedback if something has been updated when they were sending the transaction, which I guess might make sense if something has been signed a while ago. So yeah, that's kind of a safety measure that comes with this. Obviously, there are some security concerns, but my guess is that this is not significantly more different from the other custom contract functionality. Basically, it can withdraw funds from it or something like that. There are some angles to attacks in this contract and so on and so forth. So basically, it's ultimately on the contract developers. And the good thing about this approach is that it is very easy to tell that the contract is upgradable. Like it cannot be obfuscated as far as I understand, because you need to call a host function and you cannot obfuscate a host function calls. It should be visible even from the WASM blobs that the contract is upgradable. Yeah, and also the benefit compared to the first option where we just allow delegating the storage access. This approach allows to easily extend the interface. So for example, say you have some NFT contract, and then after a year, NFT standard has been ironed out and some new functions have been added to it. You may just update implementation of your NFT and provide some new functions. That's maybe a bad example. I don't know if that happens or not, but you get the idea, right? That it's possible to extend the interface without any special machinery, and it's compatible with the current host environment. And option 3 is just another feature on top of that, where we allow, besides pointing at a WASM hash, we allow to point at a different contract and use this different contract's WASM hash as implementation. And what this gives is basically a very cheap proxy pattern where it is possible to do centralized upgrades of the implementation on a bunch of contracts. This is how I have noticed some bigger contracts work, like Uniswap, I believe, where they have some implementation contract, and it can be updated in various ways. For example, there could be some voting or something like this. So again, authorization is kind of on the contract writers, and it can be as complex as needed. And then as soon as the implementation is updated, every instance of the contract gets update immediately, which is both fast and cheap. And it is of course, a more narrow use case than just upgrading a single contract instance, but arguably it is pretty important as well, because, well, it affects maybe a smaller fraction of the contracts. These are likely the most meaningful contracts, like Uniswap. So basically, this will probably concern any token implementations and stuff like that, because this tend to have many instances, and they probably should be controlled by a single entity a lot of the time. So yeah, this is options. Option 2 is that is all the pairs are there, so it's only a matter of review, and it's pretty easy. Extending it is not hard as well. So I don't see a very good reason to not do that, besides maybe some additional UX complexity, but I saw some folks had some problems with that, so I just speak now.
So I do feel like there's one possible solution that is not mentioned here, and it may be because it's really bad from a performance perspective, but you can always create a simple kind of contract that just stores things, so like a storage access contract, and then the proxy can like can pass that as an argument to whatever implementation contract it uses right now, right? And that's something that's pretty much doable now.
Yeah, I guess that's an option that kind of that's of house supports for option one. It is still like still wouldn't allow for the interface updates, as I mentioned, and of course this is really slow, and I think it's slow enough to the point of being, as long as you are touching the storage more than like a couple of times. But yeah.
Separate to the performance issue, I am curious on how authentication auth would work in that flow. Like, would the auth be between the two contracts, or like how would you, like, the nice thing about auth, the user's auth with the contract is you're sort of like scoping that user's access, potentially, but would we be able to do the same thing for a contract that's deep? I guess we can with auth next.
Sorry, like which approach are you referring to?
I'm just talking about what the idea Toma was sharing, where data is.
I guess it doesn't really matter. You just like your storage interface, instead of like calling storage through the env, you would call storage as another contract, and another contract would rely on the invoker being the admin, something like this. So basically, it is definitely doable. Whether or not it's a good idea, I think probably it's not the best idea. But I mean, yeah, it kind of works.
And presumably it's a bad idea because we're talking about what I described has like 3 separate WASM environments in it, right?
Yeah, it's a ton of the cross VM calls, and I mean every storage read would be another VM read or write would be a VM call, and VM calls are really expensive. That's the most expensive thing you can do, which is why kind of in favor of built-in mechanisms, because besides providing some unique features, they are also much more efficient and avoid like additional VM instantiations, which are expensive.
Right, but if we go in the path of introducing protocol changes for this, you can imagine that like and again, I'm not attached to this idea in any way, but you can imagine a world in which we take this, simple contract, like simple storage contract, and nativize that, so that it's native code.
I'm not sure how would we nativize it. It won't be possible, probably.
So is that worth doing? Like, I'm curious why that approach is more beneficial than solution 2, like just using the host function.
That's a good question. So I think solution 2 is passable. My knee-jerk reaction to solution 2 is that the fact that a contract's implementation can change is not trivial. Like it's especially if you look at other smart contract platforms out there right now. I feel like that is going to be something that is a bit more difficult for people to wrap their heads around.
I'm not sure how is it different from the proxies where implementation change is exactly what happens. It's just that instead of changing the contract that is serving as implementation, you are changing the implementation itself, which is actually easier to trace in a generic fashion because it's independent of any contracts.
Yes, from a user perspective, I agree with you. But if you look at the USDC contract, which is a proxy contract right now, this it never changes, right? It's always still the proxy contract. and the state changes, and there's like a different address that it forwards to. But the contract itself didn't change, right? It's from like an observer perspective, like a block observer perspective.
Well, is it actually a good thing? I don't think it is a good thing.
I think that's a good thing because I think the fact that the actual code that runs, like the fact that the actual contract code, and this is semantics. So just
But
from
that's the thing, right? It's a contract behavior may change, and it is actually hard to notice that it has changed. Whereas in the second solution, will even emit an event probably, and it will be very clear that the implementation has changed. I think it is. It actually makes things more observable and safer, right? Because well, you can argue, yeah, it is just a proxy, right? But it may point at a different implementation, and if Block Explorer actually cared about that, it would be pretty tricky for it. Like, it would need to know how exactly this proxy reference is being stored, or introduce some standardized events or something. So I don't quite agree that it's necessarily a better thing, because it creates a false impression that the contract doesn't change, or it actually, like, its behavior actually does change, in fact. But it's just obfuscated.
Yeah, I think there's basically no way for us to. I agree with Jima here. I think there's no way for us to prevent contract behavior from changing. Contracts can just change behavior. That's their nature. They don't always. If they did one thing yesterday, they don't necessarily do the same thing today, because they might have code in them that says, if it's Wednesday, do something different. Right? There's always the possibility for contract changing. What you're getting out of something being built into the protocol is a standard way of expressing a pattern of contract change. And so block explorers or anyone else can actually observe that particular type of change, which is upgrades. And upgrades are, the least pathological and most expected type of contract change, which is that someone just pushes an update to their contract because, like, life goes on and they've added features or they fix bugs. That's something everyone does in software. And so I think expressing it in protocol is actually a good idea. I'm in favor. I think 2 or even 3. I think 3 can be layered on top of 2. Like, it can be done as a future extension. So if we're just going like MVP, like, we could just do number 2 initially and then have, an additional flag on the thing called indirect reference rather than direct reference. And that's not the end of the world. But I think building into the protocol, I mean, this is like, I'm a broken record. I always want to build stuff into the protocol. So this is no surprise coming from me, but I'm definitely on the do it in a protocol level. It's 100% of contracts are going to want to upgrade themselves at some point. So it feels like supporting that is quite natural.
Yeah, I think that was a really good explanation from Dima and Graydon. I've changed my mind.
Also, one more point, like, you have mentioned nativizing the contract. I don't think you have a good user story for that. But I think actually this functionality probably can be leveraged, because I'm not 100% sure if we'll be ever able to kind of make current contract implementations native without a lot of hookups, especially like if there are alternative implementations of the same interface that are slightly different. Which means that, in the future, you could say update current contract not to WASM, but to a native implementation. So that's another consideration and another benefit of having this in protocol versus just something ad hoc built with contracts.
There's one aspect of the way we're implementing this that I saw getting discussed in Discord. There was conversation about changing how auth worked with updating so that signatures for auth included the WASM hash itself, so that if an update occurs, everyone's signatures get invalidated. I'm curious, I guess, like, what the motivation for that is.
Yeah, to be clear, I am kind of neutral to that idea. I think you can either do it or not do it. The motivation was mostly about certain security implications. Like it adds some degree of additional confidence, right, in what you're signing. Coming back to the Timur's example of, hey, is this the same contract? Well, you kind of can be sure. And I think this makes the most sense when probably you are more concerned not about the implementation changing to something that is clearly malicious. Say, there was a token balance and then there is an update and admin now can transfer your whole token balance elsewhere. Well, they probably can do this anyway, but I get the point, right? So, like, we are not talking about malicious upgrades here, but let's say you just want contracts to be audited if they are updated. Like, you do not trust contracts by default. Let's say we have some database of trusted contracts, right? And if the contract is getting updated, chances are it won't immediately get to this database. For example, you can connect your wallet to it or something like this. Which kind of makes it reasonable to just sign for a certain contract implementation, and if it has changed, then you'll basically get alerted about this or something like that. So basically, your wallet will be more aware about what you're signing, and there is more possibilities for the audit. What it's getting signed. Of course, this is all just theory. I don't know if this will happen in reality, but this is something that we enable if we add implementation to the OS payload. So that's the idea.
Okay. Yeah, because it sounds like I wasn't sure if this was like part of the core idea of what we're trying to do. It sounds like it's something we're just sort of considering on the side then. Yeah, I think my concern about it is that it's more of like an advanced user. It sounds like more of something that like an advanced user would care about and not the general user. And to enforce something like that on the general user, I think would actually create problems. In the moment that a contract upgrades, anybody who's currently submitting a transaction is going to fail. The vast majority of those users probably don't care, and they probably just want to going to have to go re-sign something that they would have been happy to go through anyway. And I think like we always have the weak link that a contract developer could just implement the proxy button so that the thing that you're signing doesn't change, but the thing where the logic actually is will.
Yeah, sure. It's I guess, as I said, it's more about the question of trust. Basically, let's say you have some swap contract that doesn't actually hold any balances, so you don't really care about if someone can suddenly drain funds from it, but you do care about its implementation. And again, this kind of needs some mechanisms for accessing some audited implementations. Without that, of course, it makes zero sense. With that, it makes some sense for the cases when you have some contracts that or state doesn't matter much, because yes, contract proxy pattern could be implemented, right? But then, like, would you trust this contract in the first place, right? If you're talking about this use case where you worry about contracts being audited, and
Right.
that's something I don't really know for now how that would work, right? Because in general, having some trusted contracts, contract implementation databases is something that seems like a good idea, but obviously this will need to be built by community, and I don't know to which degree how to cover all the cases. So yeah, as I said, I'm kind of partial in this idea as well. I understand some arguments for it, and I understand arguments against it. That, for some it will be just an annoyance. Not sure. Maybe we should ask for T-Boss and Pinker's opinions because they were advocating for adding it. Maybe they have more arguments as well.
Right. Yeah. So I don't disagree that this probably has some utility, but I feel like there's an opportunity for us to implement this in such a way that it's not required. It's not part of the, like, if we make it part of the signature, then in theory, everybody has to buys into this model, this very, very overcautious, I'm only going to use something that's, yeah, like basically buying into that. Whereas if we find a different way to implement that requirement, such that it's not actually part of the signature, but maybe of the invocation, but maybe it's part of the, like we have the footprint, for example. Maybe we have something like the footprint that lists out the WASM hashes of the contracts that you're invoking, and the protocol just checks that. So it's not actually part of the signature for the actual invocation, but it's part of the signature for the transaction, maybe. I don't know.
Yeah, actually, that's a great point now that I think about it. You kind of, oh, it's not you, it's a transaction source who is signing the footprint. But that's an interesting point. If the contract updates, the transactions will anyway fail because they're accessing a different ledger entry. It's just kind of interesting, right? Of course, it needs to happen in the short time window between like pre-flight snapshot getting updated and the contract should update within this window, and the transactions will still fail. So,
yeah, I don't know if it would necessarily be part of the footprint, but maybe something like the footprint if it can't be part of the same thing.
yeah,
Just where you could list out, these are the contracts that I'm willing to be executed in this.
Right. Yeah, but really thinking about it, seems like the window where you would sign something. Basically, you could just do this off chain, right? Maybe we shouldn't really worry about plotting the transactions with this because, like, if you really care about that and your wallet has some logic that can that has some base of trusted implementations, right? It just can be maintained by doing some read-only requests to the ledger snapshots that are reasonably fresh. And probably from the security standpoint, this won't be really that much different from signing the WASM hash because the time window for the contract has been updated, but the snapshot of the ledger hasn't been updated, kind of coincides with the pre-flight call anyway. So your transaction will still probably fail because it has invalid footprint. So maybe signature shouldn't be even concerned about that. Like, first really need to align for you to basically sign a call without knowing that the contract has been updated and actually letting it pass. I'm not sure this is possible. So, yeah, I think that's maybe a good point, and we shouldn't worry about it too much. And it seems like the just wallet side implementation is reasonably safe. If you really are concerned about what contracts you're calling. So, yeah.
Are there any other open questions, Dima, about the implementation of proposal number 2 that you want to consult with the group?
Not really. I think it's super straightforward. Yeah, I think it's pretty easy to use and doesn't introduce too much burden on us as well. So, yeah.
Okay. Are there any other questions from anyone else on stage or in the audience? Okay. This has been very productive. Thank you all, and we can keep chatting on the on Discord if you have any further questions. Have a great day, all.